Start recording. Okay, hello everyone and welcome to Handmade Hero. I know we are staring at the Emacs screen. That's a little bit weird. Normally we're not doing that on Handmade Hero. It's because I was explaining something in the pre-stream to somebody. We had this little situation happening there. And so I'm going to go ahead and close that down. That was just a little pre-stream chat. We were chatting about some stuff and I wanted to demonstrate. But here you go back to the standard where we normally start at the episode. Welcome to Handmade Hero, the show where we code a complete game live on Twitch. And you know, yesterday we kind of just went... I was surprised at how well yesterday went, to be honest with you. I didn't really know how it was going to go. And we just straight up replaced our other debugging system with one that basically does all the same stuff but captures the full information, including the timestamps and everything. And that was pretty awesome. And I'd like to go get back into that today because we haven't really played with it. Now that we have this extra information, we haven't done anything with it because we just finished up actually collecting it. That's pretty cool. Now, there is a slight issue with it. And it's an issue that, honestly, I haven't had to solve recently. In professional programming at Mali, because of the way that I do things, there's a different way that I structure the code that makes it so that this particular thing is not necessary. But I know that we're going to have to solve it here, and I'm a little rusty. I'm sorry to say, I'm just rusty with the technique that we're going to need to use, or at least I assume that we're going to need to use, unless the correct solution is just to kind of switch over to the way that I do it at Mali, which I don't know that it necessarily is. I think that's a little bit further down the rabbit hole than probably we would want to go for the code that we're doing right now. But I'd like to get back to it. I'd like to talk about some of the things, the shortcomings that we still have in there. Can we fix them? And and then which ones we can leave. And then I'd like to go, if we still have time after that, which I don't know if we will, I'd like to start going into like how to use the data a little bit more. And then for certain tomorrow and Friday, I'd like to sort of get into, okay, let's make some nice vizzes now that we've got this extra information. Let's fix the visualizations we were doing from before to sort of have the information that now we can provide, such as knowing how much time a function took exclusive of its children, of the people that it called, for example, right? Or knowing when things happened relative to each other. That sort of stuff. And that's sort of stuff that I would like to be able to see in that profile. I'd like to have a really nice profile view there because, you know, like you've seen so far, it doesn't take that long to do this stuff. You know, in a couple weeks of Handmade Hero time, which is, you know, something like a few days of full-time programming time, you can build yourself a pretty nice inline profiling system. And there's really nothing like that. Having that nice inline profiling system really allows you to kind of just always have a heads up, kind of a rough idea, you know, of what your program is doing without having to go into some kind of mentality that like, oh, I'm profiling my code now. And so you never have to worry about like, oh, launching up some external profiling tool or these sorts of things. So having that inline profiler, even if you do end up using external profiling tools because they have some features that you want that you don't have time to implement or whatever, having an inline profiling tool is usually a really great idea because it's all about keeping that situational awareness of your code so that you always know what's going on all throughout the development. It really helps you keep performance in mind. It really helps you spot bugs, weird things happening earlier rather than later. And it prevents you from getting into the situation where you suddenly open up this sort of really, you know, you're opening up the trunk of the car and all the dismembered bodies are in there sometime at the end of the project. That's not the best place to be, right? You'd rather always know what's going on and kind of have this sort of heads up idea of like where's my time being spent, roughly how many times do things get called. Having that in mind all the time helps you make really good architectural decisions all along the way so that you're not just slammed with it at the end and going, oh my God, like what do I do now? Have I painted myself into a bunch of corners? Like what do I do? So having that information all the time I think is really good, and that's why I think spending this time is good. And like you've seen, it just doesn't take that much time. We're talking about a few hours here, you know, 10 hours, 15 hours, something like that. To build a pretty good system from scratch is really a very small time investment on any project. And so I really highly recommend keeping that going if you can in your own projects. And certainly I'd like to do it here on Handmade Hero. So anyway, I guess before I get started, I should mention it's day 182. If you have pre-ordered the game, handmadehero.org, and you would like to follow along, day 181 source code is what I'm starting with today here on day 182. If you want to follow along, unzip that. If you are using the GitHub, use the tag, browse by tags, and grab tag 181, and that's where we're at. So however however you're getting your source code these days, whoever your source code hookup is there, whether it's the zips or the GitHub, go ahead and get that day out, and that's where I'm going to be starting at. Now, if you remember what we did on the last stream, we had just finished up making sure that we could run with sort of this new system and that everything seemed to work relatively well. It does, and that's pretty cool. It's a little slower than our old system, but I have a feeling, I can't say for sure, but I have a feeling that a lot of that has nothing to do with the insertion of the timing. I think our timing code is probably still pretty darn efficient, and I suspect that pretty much the entirety of the additional time spent on behalf of the system is in the collation phase. And again, that's totally fine. If collation takes a long time, and you know, that's where all the time is spent for this particular profile system, it means that we can't really run the game at the full frame rate while we're viewing the profile, right? But we can certainly run it at the full frame rate, then pause and view the profile, for example, or any other things like that. We can always sort of compensate for that stuff. So if it's just the collation phase that's slow, that's really not going to be a problem. So as we dive a little bit deeper, and keep that in mind, the inline profiler slowing our game down is only a problem if it's slowing the game down inside the actual code that we care about. If it's all stuff that can be isolated into a post pass, which I believe it already is, because I think we did a reasonable job on it, then we really don't care, because there's plenty of ways we can get around that. Plenty of ways we can get around that that will make it so we don't really have to care, and that won't affect our ability to use it, I don't think. So anyway, what I'd like to do now is go ahead and talk about what we are actually doing here in terms of how the buffers work and some limitations of them, right? Okay, so first the limitation that I don't think I'm going to fix, and that I don't know that we really ever would need to fix. And that one I just want to get out of the way so that we're all aware that it's there. And I'll put it to do in just to talk about it here. I will say to do, Casey, no attempt is currently made to ensure that the final debug record being written to the event array actually complete their output prior to the rollover or the swap of the event array index, right? So what I mean by that is we have this global debug event array, and I have two of them because as these events get streamed out into the system and are recorded, we want to be able to be doing that continuously from as many threads as we want, and we don't want to have to put any restrictions on it. As a result, when somebody goes to actually gather the information, there's no way for us to actually look at the data there. You know, we can't sort of say, okay, the buffer's done, go start reusing it from the beginning. We can't do that until we've read all the data, and reading all the data might take some time. Meanwhile, some other threads want to be able to write to it. And we don't want to introduce a mutex or anything like this, because the whole point of our timing blocks is we want them to be as fast as possible. And they're just like write directly to the debug log, and that's it. So because we've done it that way, it means we need sort of a double buffering system. We need to make sure that we are writing to one while we're reading from the other, and then we just in one atomic call swap them so that we know that we never have a conflict. Now that's all fine, but what it does mean is that if somehow, and it's incredibly unlikely, but if some bizarre thing happened where a thread got its debug event array index back from the synchronous operation, had not written to it yet, and in that period of time between when it got the index back and literally like it just got preempted right there and held on preemption for the entire time it took the other thread to swap, do the atomic swap to the new buffer, and then parse the whole debug buffer all the way to the end where those missing elements are, and then read those missing elements before they were written, it would get bogus information, right? The chances of that happening are effectively zero, I think. I don't think there's probably any way it can happen. It would be really crazy. Maybe if there were a lot less debug events in the array, it might happen once in a while, but we're talking about a debug array that has potentially hundreds of thousands of entries in it. Remember, it had more than 64,000 entries in it already. So we're talking about a massive log. The chances of that happening, I think, are extremely slim. And if they were to happen, I think I'd be okay with that. So we'll just put it that way. Now, famous last words. Maybe that'll come back to bite us, but I'm just not that concerned about it, so I'm going to let it be. And I don't think the costs of fixing it in terms of how that might affect the lightweightness of the ability to time those blocks, I just don't think it's worth it at that point. Okay, so that's what's going on. That's a limitation that I think we're just going to live with and be okay with. I don't foresee it causing us very many problems, and I hope that is true. But now we've got some limitations that we do want to fix. And those specifically are about, this stuff that I didn't do, right? It's not like the system had a problem, but if you take a look here, I don't know what core index I'm on. I don't know what thread index I'm on, right? And so that leaves me in a situation where I can't really do the work that I actually want to do. And the core index part is a nice to have. It's just nice to know so that we can see, if we want to, what cores our threads are running on, how they may get moved around, that sort of stuff. That's just nice information to have if we're doing profiling work. No big deal. We could leave that one as 0 forever and not really care. And I was kind of hoping to get that out of RDTSCP, but maybe that's too much to ask, and so maybe we won't. So maybe fixable in the future, maybe not, I don't know. Something to think about a little bit more, but not that critical. Thread index is the big one. Threading index is absolutely crucial, and the reason the thread index is crucial is because some of our threads call the same function. So for example, if we want to do profiling of our renderer, which is something that we we've already done some profiling of the renderer, it's a very time critical component. The chances of us wanting to insert profile counters into the renderer, very high. But the problem that we have there is many different threads are using the exact same functions. What that means is we cannot assume that any given function's begin and end are happening on the same thread. So we may see a begin event for one of our blocks and then an end event for one of our blocks. We don't know if that end event was from some other thread finishing that function or from the thread that the begin was on. So we need some way, right, of being able to determine how these things line up in a thread sense. Now, since we know that threads always are sequential, meaning inside a given thread, we're never going to have that happen because threads execute things in order. It's not like multi-threading where different things happen different times, right? So for a single thread, if we see begin, 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 end, 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 we know that the first begin goes with the last end, and the second, we know that they line up, right? Because a thread can only enter a timing block and then leave it, and any entry that it did into another timing block would have to happen, as something sort of subordinate to that, and it would go in that order, right? But if we have multiple threads in the mix, that's no longer true. They can begin and end at arbitrary times. We don't have any way to pair those up unless we have some kind of a unique identifier that tells us which thread was weaving through here, which was the one that allows us to pair up those begins and ends as being the same, right? Okay. So we have two options for solving this problem. Option one is we figure out a way to get a thread index. We figure out a way to get some number that is unique to the thread that it's executing on, and we use that. Now, the reason that I like that the most is because that allows us to tell other information, such as what threads we're doing what when, so that we can have a picture of our threading baked into the log as well. And that's extra information that I would like to have. Now, we're not crazy threaded in Handmade here. We have a few things that are threaded. It's not a complete crazy thread thing. We got like asset threads, render threads, and some background compositing threads, right? So we have threads, but we're not thread crazy. Our game is not all about multi-threading or anything like that. So if we didn't want to do that, that wouldn't be the end of the world. If we find that it's too onerous to do so, that wouldn't necessarily be the end of the world. Because the other thing we could do is, since we know that the begin and end blocks are paired, what we could also do is introduce another counter, another U32, that just gets atomically incremented every time. And instead of thread index, it would just be like unique ID. And at the top of the block, we would synchronously increment that counter, put it in, And then on the end block, we would use that same value so we could pair them up. And since we know that each one of those will get a unique one all the way till 4 billion when the counter wraps, which, let's be honest, is not going to happen inside the course of one frame, because this debug buffer, first of all, would overflow, for starters. But yeah, since that we know is not an issue, we could easily do it that way and get the base level functionality out of it, right? We could get the basic idea out of it, which is very specifically making sure that our begin and ends pair properly. So very straightforward, could implement that immediately. If we wanted to do that, we could do that. So the only question is, can we get a number that corresponds to our thread index in any easier way? And so what I'm going to do here is I'm going to first talk about in Win32, there is a way that we can get the thread ID with a function call. Now, remember, function call, not really something that we want to do in the middle of a timer block. So what I'm going to do is I want to look and see if I do get current thread ID, I just want to see what that would do if I called it, right? So if in here I have a thing where I'm going to do get current thread ID, and I just go, thread ID like so. And I guess I'll put this in the Win32 layer so that we don't have to complicate things by including windows here or anything like that. I just want to see what it is actually going to do, and so that we can have some opinion about that, right? So here's WinMain. Right on the entrance to WinMain, I'm going to see about getting that current thread ID. So I'm going to pop over to the debugger, set a breakpoint in WinMain. Oops, try again. Set a breakpoint in WinMain. And here we go. And what I want to do is I want to look at the assembly. I want to see how expensive it is when it tries to get that out, right? And so you can see here we're in the assembly, right? Here's the code bytes. Here's the parameters to the call. It's going to call out to this function. And so what I want to do is I want to step in there and I want to see what it's actually going to do. It goes into, I assume this is like the dynamic linking jump table. So let's go ahead in there and see what it does. So it looks like, this is what I suspected. It looks like it's a really straightforward thing. In order to get that thread ID, you can see that it's just referencing off the GS, which is a segment. It's sort of loading in. I can sort of see if I can get some information here. It's loading into RAX. It's loading in this pointer here, I assume, because you can see that it's about to use it as addressing. I assume that's our thread local storage. So that's basically a pointer to memory that's specific to our thread. I assume that this is some segmented addressing, right, where the threads themselves have, each individual thread has a different GS segment for addressing set. So then we go ahead and move off of that address. We move it into EAX, which is the return register. So there we go. So getting off our thread ID out, for example, is really as simple as addressing off of this GS right here. So what that implies to me, and this could be a little bit presumptuous of me, but what that implies to me is if all I wanted to do was have a way of knowing what my thread actually was, it shouldn't be too difficult, right? It's just 2 instructions to access thread local storage, the local storage for this thread. And again, we haven't really talked about that. So maybe I should just say really quickly what that is, but I'll postpone that for just 5 seconds. I just have to figure out where my thread local storage is by using this GS segment addressing. And then I go ahead and address off of that into a fixed location to get the thread ID. But at some level, this is already a thread ID, right? Because whatever the address of my thread local storage is, if that's unique to every thread, I could just use that. So really, just RAX, just this one keyword move out of the GS segment, that one move is all I would need, just one instruction, and grab it. So, what do I mean by thread local storage? All I mean by thread local storage is most operating systems these days, when a thread begins. So you saw us, we had create thread, right? You remember this stuff, hopefully, for those of you who watch Handmade Hero regularly, we've got this function, create thread. When we create the thread, we obviously get one thread at the beginning. When Windows calls our WinMain, it's calling it in a particular thread. It's our main thread. and then we create other threads, give them pointers to functions. Windows will create a thread for us, whatever that means to Windows, and then start executing the code at the function that we gave it at that time on that thread. Now, when it creates the thread, both for our initial startup thread and for the threads that we create, what it does is it sets aside some memory that it's like, this is memory that's going to be unique to this thread, right? It's like a little section of memory that's like, this is for this thread, and it sets up some known segment addressing, some predefined stuff in the memory table, basically. That's, in fact, I think we might, yeah, there we go. It's actually right there in the actual registers. You can see the GS segment right there. This is the value that it's actually got. It sets up this concept of a location that's in the CPU registers, in these extra segment registers, right? Which are, again, things kind of that used to be like, they were kind of a holdover from the old days when you always used to do segmented addressing. Nowadays, we think of addressing as always flat, but there's no reason you can't kind of consider there to be segments where you say, oh, I want to address off of a particular segment register, and say like, okay, when I give you a value, instead of you thinking this is my normal memory, I want to tell you what segment I'm going to go off of. So if you look at here, this is an example of I'm taking some address and I'm addressing 48 hex off of that address, and I'm going to load it. That's just my normal standard addressing in sort of the default segment, if you will, of my virtual memory. This GS segment is a way of saying I want to address memory slightly differently. The address is based off of this other piece of information, right? And the reason that they use that in this case is because what they do is for every thread, when the operating system switches between threads, obviously it restores the register state of the CPU. So like, for example, if a thread is running, it gets preempted, another thread runs. During that changeover, obviously it has to restore all the register state, because whenever it preempts something, it's got to save what the registers were, because the code needs to be resumed at some point and have all those registers come back. One of the things that it restores are the segment registers. So each thread can have a segment register set to a different value that allows it to have effectively thread local storage by saying anytime you want to access some information that I believe to be specific to your thread, I will use the GS segment instead of normal addressing so that I can get you different information than what when some other thread would have gotten, right? And so something like that thread ID, Windows always stores it in exactly the same place for every thread in relative to the GS segment, but that GS segment is actually pointing to a different place in memory for every thread, right? And so that's how that sort of situation works. And that's, you know, that stuff is way before my time. I don't know really anything about segment addressing. I only know as much as I just said. You know, so I unfortunately can't really tell you much else about things like the GS segment or these other segment registers. Like that's way outside my area of competency for sure. But it's something that an old school DOS programmer would have known about a lot, because segments were a much bigger deal back then. Because all memory addressing was all about segments all the time. And it wasn't like you had this concept that one particular method of addressing was like the main way, and then there were segments for special times. It was more like a little more sort of segment-oriented than that. So anyway, what I can see there is that that's something that doesn't really require a function call at the end of the day. So what I'm kind of wondering is there some kind of intrinsic I could use? I mean, obviously I could just do that directly myself, but is there some kind of intrinsic I could use to get that? So for example, if I just want something like thread ID intrinsic, some way to make it not have to drop a function call to do that every time. And I don't know if it's likely. Yeah, this is not looking particularly good. This is talking about sort of other sorts of stuff. And what's kind of frustrating about that is we know it's possible, right? It's just a simple MOV. So it's kind of unfortunate to think about that. But let's see, in Win32, let's see if there's, I don't know if there's any real way to do that. Accessing the TIB. So you can see like they're using inline ASM there to do it, which is, you know, again, not what I would really like to do. Here we go with using Microsoft's intrinsics. So they've got an underscore read DFS word there. So maybe we can do something a little bit cranky here. And again, since this is debug code, one of the benefits is even if what we do is a little bit janky and doesn't work reliably on end user systems, it's okay because this code will never run on an end user system unless we make a mistake and ship it. But we would fix that. So the idea is the profiling blocks will get compiled out, and so we don't have to worry if it only works sometimes or in some places or only on x64 or stuff like that. That's actually okay. So let's take a look and see MSVC compiler intrinsics. I want to see if I just look sort of directly in there. Can I find anything that's like talks about threads or anything like that? It doesn't look like it. So let's look at moves. There's that move DFS word intrinsic there. Let's just take a look and see if we've got it. Move. Let's see. Doesn't look good here. Does not look good. Let's see. Access GS segment intrinsic or access GS intrinsic MSVC. Let's see. On Microsoft segment, some details. Let's see. The GS register does not relate to the stack at all. Next register is used to point to the operating system data. Instead of FS segment descriptor, let's see, FS and GS segments in long mode. Just are only available in kernel mode. Oh, that's unfortunate. You know a segment mode GS is pointing to, so in kernel mode you won't need to know the address. Personally, I don't know what the use for these would be. Well, that'd be too bad if that was true. How about this? Read memory location from a location specified by an offset relative to begin the GS segment. Well, what do you know? That sounds like exactly what I want. So it does look like that read GSD word would be sort of exactly what we would want. So I don't know. Like I said, not something that I've worked with before. I'm just kind of winging it here. So I'm going to go up. I'm going to go up in here, and I'm just going to say, you know what, folks? Let's go ahead and read GSD word. And I'm also going to do, you know what I'm going to do too? I'm going to go ahead and say that maybe we just straight up look at exactly what that thing was doing. Because remember, it was, oh, hello. Nope, no, it's fine. Don't, stop it. Stop. Don't. Do not. There we go. So I'm just going to go ahead and step in there, or not. I'm going to go ahead and step in there, I said. Okay. I'm going to go ahead and step in there after the jump. Double jump. Double jump. Yep. The compiler, Windows likes to double jump. It found that Metroid upgrade. So you can see we're accessing 30H off of that, right? For starters. And I assume that is our thread local storage segment. That's what I'm assuming anyway. So you could imagine us reading a D word off of that segment like so. That's going to get us back a pointer, apparently. This is our thread local storage, I guess. Again, totally just going by the disassembly here. I have no idea what I'm doing. Literally, I'm just reverse engineering pretty much exactly what I think I need to do in order to not have to do a double system, a jump into a system call and crap like this. So I do that, and then I get back that pointer, and then I'm going to go ahead in here and get that 48H off of the pointer, right? So that's going to be a reference off of there. So yeah, so when I do this, well, you know what? It's reading a pointer, so a D word's not going to do it. Do I have the ability to read a quad word? I do. So I can read a quad word out of there, right? So I'm going to assume that that's a pointer. And again, it's reading a D word. It's a D word the next time round, right? It's a D word read. So what I'm going to do is I'm just going to assume that this points to a D word. There it is. I'm then going to go ahead and grab it. This is our thread ID number 2. And I'm just going to say, OK, so 48 hex. Here's my thread local storage. Although I guess technically I want this as a U8, so I can address off of it as 48. My thread local storage plus 48. If I treat that as a U32 and then dereference it, I believe that will give me the thing that I want. Now, that may be protected memory. I don't know if I can even access that. I didn't see a ring transition there, so I don't know if that's true, but I don't know if it would show me that in the debugger anyway. Read GQD word is not found. Did I? Oh, whoops. It's GSD word. There we go. Keyword. There we go. Let's go with that. So I don't know what this is going to do at all. Again, I'm totally just playing around here to see what I can do. There's the thread ID. So it's thinking it's hex 1094 is the thread ID. Here's my thread local storage. Looks like it gave it back to me, and it looks like it's the same value as I was getting before, or something similar. Like it's up in that range. So that's good. Grab that thread ID. What do you know? Look at that. Look at that, folks. So now if we take a look at what happens in the disassembly, right, we can see that this is actually just totally perfect, right? It's just one instruction even to get that GS pointer, which I know has to be correct. I can even ignore the thread local storage part probably, although I don't know necessarily. I don't know if I need a second mov, but in order to get the Windows thread ID, doing one extra instruction at every block start, not a huge deal, might be worth it. So that's kind of cool, right? That is kind of cool. I'm pretty happy about that. So let's just take a look at what it would take to go ahead and throw that in there. I'm going to jump into Handmade debug here. When we're doing record debug event, if I wanted to make that happen, it would be this, right? And there's our thread ID. And so if I then want to put that in thread index, I can do it like that. Now, we do have a problem, which I think our thread index is only a U16. In fact, you can see right there that it is only a U16. So there's that. Since we don't have the core index yet, I could just say, what the heck, make this be a 32, so that way I don't have to worry when it comes back. But for now, we could just chop it. We'll see how that goes. Oops, I meant U16. Thread ID, there we go. And so there we go. Now, I feel like, in general, that is just totally fine. And if we go into Handmade intrinsics, inside compiler MSVC, I can then sort of abstract this out because I don't know that that's actually going to work anywhere else. We probably need to use a different technique on another platform. So if we want to get back thread ID, like so, then we need to do this on MSVC, or on Windows, I should say, however you want to think about that. At the moment, they're the same. We might have to differentiate more by platforms later. But that's what we would do, right? We do that read GS word, the thread local storage, so on. So yeah, so that's pretty cool. That's really all we would need to do. And then we just return that value, and we are good to go at that point. So in theory, we can replace this with get thread ID, and now we're still platform safe to a certain degree, meaning that we can still run our profilers on other platforms by implementing those functions once we are actually on those other platforms. So there we go. Okay, so that, I believe, now gives us accurate thread IDs in theory. As part of our profiler, does not involve any operating system nonsense and should not slow us down, especially in an optimized build when that stuff gets inlined. So if we go over here and we check like build.bat, if I switch this to an optimized build, which is what we would be using for profiling, then in theory I should be in pretty good shape, I would think. So there we go. That's where we're at the moment. And we've got our thread IDs now, so that should give us plenty of ability to sort of be a little bit more fancy and get a little bit more data in here. So that went a lot more. That went a lot easier than I thought it was going to go. I lucked out. Assuming that we're actually getting a reliable thread ID out of that, that was really smooth. So yeah. So we can go ahead and start right now putting together a better debug view than this one now that we have that more information. And so what I'd like to do is I'd like to start, I think what I'd like to do is start having a concept, if you will, of when blocks begin and end and this sort of stuff, I'd like to start building more of a timeline view of things. I'd like to turn this thing down here because I really like these kinds of displays. I'd like to turn this thing down here into something a little more usable that shows us kind of what's going on in terms of how our code is who's taking up the time in our code. It's kind of like a pie chart, right? Every one of these lines is showing us what's going on where, and you could already see how easy it is to tell if we added some ability to like figure out what functions these were or whatever. You can already see very dramatically who's taking the time, right? The giant blue bar is the problem, not the little tiny green bar, right? And so I like having that ability because that's the kind of thing that allows me to sort of get more information about what is occurring. So, okay. Since we have about 20 minutes left in the stream, Since we have about 20 minutes left in the stream, I think what I'll do is I'll sort of postpone improving the viz itself till tomorrow when we can start right at the beginning on improving the viz. What I'd like to focus on today is getting rid of this thing, if I can. So if you remember, we pass this debug frame and info thing in here. And the only reason I was doing that is because there's no way to get these debug counters to work at all on the platform side of things. But what I'd like to do is figure out a way that we can turn that around. I'd like to figure out a way that we could have the debug counters, I'd like to figure out a way that we could have it so that the platform code can be unified with our regular debug code such that we can use the counters on both sides of the program, which is a little tricky, but I think we could do it. I can't think of any reason in my head why we can't do it. Just a little bit tricky. We have 3 compilation units. It seems like we should be able to have 3 arrays and have it work properly. And in theory, they should all be able to write into the global debug event array as well. So really the only thing that's a little bit tricky is the handmade debug.h. Code has to be factored in such a way that would allow me to expose the important parts of it. The part that allows you to record a debug event, for example, that has to be accessible from the actual handmade platform.h itself. And so it kind of has to move over, right? So I'm going to go ahead and do that, see how much of it I can get done in 15 minutes, hopefully most of it, and so that way tomorrow we can focus on improving the viz. So I'm going to go ahead and start with that. Again, you can sort of see it happening here, how record debug event works and how timed block works here. So what I'm going to do is I'm going to try to pull those out, put them into the platform layer here so that they actually are part of this this system right here. Okay. So let's do that. If I just go ahead and grab this out like so, right? And then I take this stuff and do the same. Then that's all the code that I actually need, right? And handmade intrinsics. These intrinsics, I guess the other thing is that the atomics that are used in here. So we've got a couple of them. We would need the add U64, right? That guy. Atomic add 64. We've got 2 of those that are happening there. Oh wait, no, we don't. This is not necessary anymore, I guess, right? So actually, a bunch of this stuff can be removed. I'll leave that for, well, you know, I might as well just do it. We don't need it right now. So goodbye. So record debug event on the start and the end is all we really need there. As far as this is concerned, we need that counter in it. That still needs to be there. However, some of this other stuff does not necessarily need to be there. We've got that hit count. I don't think we need to store any of that stuff. Looks like debug record star record doesn't really need to be stored either. So I think we're just looking at this, if I'm not very much in error about that. I would say that looks pretty much like what I need, right? And to do record the hit count value here so that we can get those sort of numerical counter things back potentially. We may want to add that a little bit later, but that's not really relevant to what we're doing right now at all. It's something I wanted to mention. So that's all the code that we need for that block. record debug event, again, needs the atomic add, and it needs the RDTSC, which we also don't really have our own call for, which we should have our own call for. And then we have that get thread ID. So those intrinsics, I don't know, intrinsics, they are not in here at the moment, right? So the intrinsics would have to get moved in here as well. Not any of these other ones. These are all fine, but just these ones specifically right here, the atomics would have to get moved in as well. So I've got to do that. Really nothing I can do about it because I need access to those. So that's going to have to happen. But first, let's talk about the more pressing. That's just a matter of kind of cleaning this up a little bit and just doing it. But the more pressing problem, right, is how do we find the addresses to write to for these guys, right? How do we actually know the location of the writes for any of these things like the debug events, right? So that part is a little bit trickier, and I got to think it through. Because if you take a look at what happens here, this right here and this right here are both sort of globals that need to be available to the debug system so that whenever you come through here and you're going to use them, you have to have a way of getting, right? You have to have a way of knowing what, what those pointers are. There's two separate pointers, and both pointers need to be respected in some way. So I don't necessarily know what the easiest way to do that would be. I feel like probably what we could do is make it so that they're always stored. They're always kind of stored on the platforms layer side, right? I mean, we can make it so that those are declared and they live on the platform layer side. When the DLL is loaded, we can make it so that those global values are initialized at that startup time. I don't think that would be particularly difficult to do. I also don't know if we couldn't possibly just have it sync those up. I feel like DLL binding should actually allow us to do, I haven't done this in a very long time, but I feel like DLL binding should be able to patch the address of the global just fine. So I think declspec import data, I think we can just make it just plain work. So let's see. If I see from outside the DLL, what is the case? It's a convenient item that removes layer of direction. When you import data from a DLL, you still have to go through the import address table before declspec DLL import. This meant you had to remember to do an extra level of indirection, right? Okay, and access it outside the DLL, you do that. When you mark DLL's declspec DLL import, the compiler automatically generates the indirection table, the indirection code for you. You no longer have to worry about the steps above. As stated previously, do not use declspec DLL import declaration on the data when building the DLL. Functions within the DLL do not use the import address table to access the data object. Therefore, you will not have the extra level of indirection present. So, okay, so that's actually probably what we want then. What that means is that we can leave it declared and operating the way that it was before, where it's actually, the data is actually in the DLL itself. And then the platform layer just grabs it. We could do that. But is that what we really want? It's so tricky. It's so tricky. Here's what I'm going to do. Here's what I'm going to do. I'm going to go ahead and say that, yeah, I'm going to consolidate this a little bit. So what I'm going to do, first of all, is I'm going to say that we have some kind of a known way of addressing this thing. So I'm going to simplify this a little bit down. So if I take a look at this here, you can see how we've got this all set up, and it's kind of got this whole situation going where we declare these things in different places and have different stuff that's going on. I don't know that we need some of the things that we were doing. So for example, in handmade.cpp, I think it is, or handmade debug, I guess. So we include handmade debug way down at the bottom, right? You can kind of see the way that we did that is we defined these things here. We no longer really care how many of those things there were. We don't iterate over the debug record array ever, right? That's not something that we actually care about. Well, no, that's not true. That's not quite true. All right. So, but it doesn't really change my plan. So what I'm thinking is, can I consolidate this into a thing that's a little bit cleaner in terms of how you actually access it, right? Can we do something where we say, all right, the thing that we're actually talking about here is going to be a struct, right? And that struct is going to have a debug record array thing in it. And there's going to be 3 of them because that's how many translation units we have. There's also going to be this stuff in it, right? There's going to be the U64 for the event array index debug event thing. There's also going to be the debug event array pointers, right? So these are the 2 arrays that we've got there, right? And so furthermore, I think I could do this by going like that and just actually having it there. And similarly, the debug record array stuff, we could just say, you know what, you can't have any more than however many counters there are. So we've got max debug event and max debug event or max debug record count, and who cares what it is? Does not matter. Something like this, pound define max debug units, and that's 3 or whatever. Translation units, something like that. Yeah. And so then this struct, right? This struct has everything in it that we would need. So this is like our debug table or something, right? And yeah, like what I would then do is translate everything over to working solely off of the global debug tables. So there's the debug table, right? And there we go. That's what it is. That's the whole thing. That's all we've got. I also might go ahead and say that this was volatile. I never really did do that. The atomics should have done it anyway, but it helps. I like having it there so I can just remember, oh yeah. Anyway, so we've got the debug table, and then we don't need any of these things, right? So that's good. Shove that in there. Get rid of this. And now we don't really need to declare anything anywhere, really. Everyone just needs to be able to get at that debug table somehow, right? And they, when we actually do our build, instead of having the 2 ways we were doing before of defining stuff, instead, we're just going to have just the debug record array index. That's all we actually need, right? And so now we can actually do this like so. And so now the platform layer can be its own translation unit. We could even make this a more formal thing like translation unit index, right? Like we could do something like this, right? And so now we just have a thing that we know. We've got 3 translation units. So let's just go for it, right? OK. So that seems reasonable to me. Certainly. And let's see if we can then go ahead and kind of, consolidate this stuff down into something a little bit cleaner. So let's go ahead and look now at the places where this is ever actually accessed. So you can see that this stuff down here is really just about storing some debug info. Doesn't really have anything to do with anything that we care about. So I'm going to go through here and see. You can see that some of this stuff is getting declared down here. I don't care about any of that anymore because I just want my debug table. That's the whole thing. Just that right there, like so. We'll call that the global debug table. There it is. This stuff now no longer has to be there. Global current event array index. That can also be moved into here, for example. That one doesn't really have to be, but I feel like we might as well. Why not, right? Then we've got the debug records optimized count. That I don't think is, yeah, those things still kind of have to be declared somewhere. We just don't have to ever do this part of it anymore, right? What we can do is just something like debug records count, you know, or wherever we want the actual counts to happen. Debug record count 0 is happening like this. We'll have to think about. You almost want something like this, right? Debug records count. And you kind of want them to have their different counter values in here, right? But that's not really something we can probably do directly. So yeah, we kind of need these extern kind of things, unfortunately, as far as I can tell. Right? We don't need the const anymore, though. That can go away. And these debug record optimized declaration, these can all go away. All we need to be able to do is say that we've got our debug records main count now as well. And that is going to be counter. Right? Then we've got that extern, and that's one that we're going to have to pull in from the other file. The global debug table is declared there, so that's all good. And then we've got our handmade optimized over here. That guy has got the debug records down here as well, so there's it getting defined. We don't need it to do the records anymore, so that's all good. And I think that's really all we would need from that. So let's continue down the road to success, which we hope lies ahead of us and not behind us. But as we go, I'm going to go ahead and pull the debug table over here because now we can go ahead and do this here, and that is actually legitimate all the time. I'm also going to pull these timed block bits down there, like so. Okay. Oh, I did that exactly the wrong way. This wants to be at the bottom of things, doesn't it? There we go. All right, so our debug table needs to be below there, obviously. There we go. And now we can just say the global debug table. That's got the event array index, like so. We can get rid of the debug parts of these things. This is just the event array. This is the record array. We could just call this events and records now, in fact. We could call this event array index and event index. In fact, event array index actually could just, yeah, I guess, well, no, you know, that needs to stay the way it is. And then we've got, this is no longer has to be called global, it's just current event array index. So that all is much nicer, certainly. In here, we have our global debug table access is now going to be just accessing that, I believe. And we have our atomics, which we have to move in. I think I had about 5 minutes on the clock, not very much. But hopefully I can finish up what I'm doing here. So then we have global debug event array. That's just going to be the global debug table dot the events array. And that is all she wrote for that. We've got the get thread ID is not imported yet. Debug record array index constant. This is actually the translation unit now. And we should probably go ahead and rename that as well. So in debug event, instead of calling it debug record array index, this is just translation unit, right? And that is something that we specify in the build, translation unit index. There we go. Atomic add, get thread, translation unit index, undeclared identifier. What? Translation unit index. It's right there. What are you complaining about? Oh, in the test asset builder. Well, all right. I guess we got to tell it that in the test asset builder as well. Not that we'll ever use this in the test asset builder, but we need it to be there. So now it's there. All right. We've got the atomic add we need to move in. Got thread ID. That's fine. Okay, so here we are in the debug record array. So that's actually going to be global debug table. And then we have our records, like so. Let's see what else we've got. Debug record array, so that all looks fine. Initializing cannot convert. That is true, because this now needs to use that translation unit index, right? It wants that specific set. So get thread ID, that's good. Atomic add, get thread ID, atomic add. Okay, so let's go and fix this now before we import those intrinsics. Collate debug records now has to know how many there are. That's not really a problem. Again, that's told to us right here. So we have basically the we have the main count, right? Plus the debug records optimized count, plus, you know, whatever debug records platform. And at the moment, we'll just make that be stubbed out since nothing's coming from it, but then we're going to want to clean that up in a second. Well, probably tomorrow. Okay, so got to move those intrinsics in. Then what else we got? Debug records main, array count debug records main. That's actually debug records main count, like so. And then again, this guy is just going to be the counter array plus the main count and the optimized count. What else we got there? Okay. Oops, that's going to be 3. This is going to be 3. And this is going to be 0 again for the moment. All right. So, undeclared identifier, debug records main. That's true, because now this is actually, in fact, we don't even need this anymore, because now debug records translation unit can just be in the global debug table. It can just look up directly in records, because we've set it up now to be working properly there. Then we've got debug record array index inside the event is actually just, again, the translation unit, I believe, right? This is looking, we changed what that means. And so that's all good. Now we can come down here to the global current event. That's just going to be the global debug table current event array index. So we're just, again, just sort of cleaning up that naming scheme there. Nothing else happening here. This is going to be the same thing. Here's the global debug table, event array index, event index. And then in here, same thing, global debug table, event array index. What was that? Current event. There we go. I believe that's correct. So now we've gotten rid of all the compiler errors, and I'll just quickly, because I want to see where we're at in terms of having things work, I'm going to go ahead and take those intrinsics out. I'm going to go ahead and pull those into the platform layer. Take an if compiler. I believe we have that set up here. We do, right? There's our if compiler MSVC, so we know that that's set by now. So I'm going to go ahead and just drop those in here at the moment. We're going to want to organize this file a little bit better. It's getting a little bit unwieldy at this point where everything is. I don't know if you can kind of see it's just a little bit out of control. So what I want to do here is I'm going to go ahead and grab these atomics and move them out. So let's grab all these guys here. In fact, I guess I can just grab this whole block. All right. So I think we're all good now. At least it looks like anyway. I also think I'm still building in O2, which I didn't mean to do. So let's go back here. And so I don't know where we're at now. We'll find out in a second. Looks like not fabulous. So it looks like we've got a bug in there, which is just in terms of probably how we organized our different translation unit stuff and all that goodness. Let's take a quick look to see what's going on there in Handmade debug. Let's think this through just real quick. Again, not going to try to debug it too much, but just want to do just a quick little check to see if I can immediately see what we did wrong. Where's our collate? Debug records. So the counter array stuff, that's doing translation unit. I think properly. It's main then optimized. Yeah, that all seems roughly correct to me. Let's take a look at handmade platform.h and see what we see there as well. When we are doing this stuff, we put in that translation unit. The translation unit is what I think it is, right? Yeah, it's 0, 1, and 2. That's what I would have wanted it to be. So we've got all that in there. Atomic end to the event index, yeah, etc., etc. We've got the records array and the event array. That all looks fine to me. Yeah. What is this guy saying here? Current event array index equals not. Whichever one is we're doing, we do the atomic exchange. We set up the swap for the current event array index. That's what I wanted. So that all looks good. The event array index and the event count get pulled out of that. That also looks good. We don't call update debug records anymore, and in fact, we can consider that not relevant anymore. Global debug event array. Why is that even still here? Why is that even still here? Global debug event array. That is our problem right there. That's not good. Why are you here? So that's our problem. That should have been this. And what can you do? All right. Little vestigial remain there. And now we're back. Okay, and so we're almost, we have like one more thing to do, which is just passing a piece of information from the platform layer forwards that says how many counters it has. But we pretty much did it. So this is great. I'm really happy about that because now we'll just be able to use those uniformly across the platform boundary, which is what I wanted. And I think we'll also be able to kind of put it in a way that now it doesn't matter how many translation units we have. That's kind of cool too. So yeah, I think we're good. And I would be pleased, I would be very pleased at this moment in time to take your questions. I would be very pleased to take some questions from the Handmade Hero studio audience. Let's take a look. Handmade tail Simiratori QA. All right. All right. What do you think is an effective way to get better at assembly? Go over a book tutorial, read the code disassembly in VS. Mike Acton can look at a piece of code for a couple of seconds and estimate how much cycles it takes and what the assembly code for it is. I'd like to reach that level one day. So I guess what I would say is there's a couple of ways you can go about it. And I think you probably want to do them all simultaneously. You definitely want to read disassemblies, like I do. When you see me drop the disassembly like we did on today's stream. You want to be doing that so that you have an idea of what the compiler is generating, and you can just sort of go, well, you know, I don't really know what this means, but I'm starting to see it, right? It's kind of like immersion, like when they say, like, you know, I want to go learn French so I can go to Paris or something, right? And it's like, okay, I start watching, you know, a French film or something with no subtitles just to start hearing it. So you get used to like, oh, I noticed when the person comes home, they say this, right? They're like, you know, bonjour, madame, or whatever. So I think that's definitely important. Do it. You know, it's free when you're debugging stuff to just do right click and do show disassembly. Do it. You know, do that. Another one is the Intel architecture manual. It explains like the instruction formats, how they work. You know, spend some time with it. Just read some various sections. Just, you know, just reading about it. Read Agner Fogg's webpage, that sort of stuff. You know, just do reading occasionally on it. And then finally, you know, write some, definitely. Like we did with the intrinsics on the renderer. start writing some stuff in intrinsics. That's not even really assembly language, right? But it's much closer than just straight C. And then you can start to think a little bit more in terms of how that's working, and your disassembly will look a lot more like what you're writing, and you can sort of start to narrow that gap. And so that's a lot of those are sort of good steps to take. Sudim73, we're actually a pre-recorded laugh track. Yes. Handmade Hero is filmed in front of a live studio audience. Cue applause. How would you deal with switching between multiple APIs in a single application like software hardware renderer? Would it be structured similar to the platform layer? That's really kind of a very open-ended question. It depends a lot on the nature of what you were doing. Software hardware renderer switching is very different than how you would switch other things platform-wise potentially. And so it's worth understanding the difference. And the reason for that is because there's a difference between wanting to switch APIs purely because you need to interface with two different APIs that do the same thing. And that might be an example of like OpenGL versus Direct3D. It's like they're basically exactly the same, right? It's like they're just different syntactic dressing on exactly the same thing. It's the same driver underneath in a lot of cases, right? With just a different set of like ways in which it sort of fumbles itself together. There's a difference between that and abstracting a renderer in a way that like, oh, I've got a totally different renderer basically for the iPad where it's like an embedded tiled renderer versus like on the PC for like SLI card NVIDIA, you know, Crazy Town, bindless graphics. The way in which you will separate those out changes pretty dramatically. And the reason for that is because the logic for the control flow, the boundary about where you draw the line for the control flow changes based on how different the control flow has to be across all of the targets. So for example, in OpenGL versus Direct3D, you may be able to put almost all of the control flow logic in the platform non-specific part of your code. And the only thing that you will actually need in the platform specific part is the specific OpenGL or Direct3D-ish calls you need to do to accomplish this exact same thing that you were trying to do in both cases. That may be completely not true for the case where you're talking about going from from OpenGL with NVIDIA extensions to Metal on the iPad. They may be like completely different control flows, not related at all. And in that case, you typically want the line of who is doing the control flow moved up significantly. And so you have to be very aware of the appropriate places to put those divisions. And the reason for that is because where you put that division, the closer that lines up with the actual variability of the problem, the more time you save in development, right? Because if the cost for putting it too low, meaning the control flow is all on the shared side and none of it's on the lower side, the cost for that is if the things on the other side, the actual implementations, they will have this problem where they have to work around the limitations of the control flow if they're very disparate. So if they are all very different from each other, now it gets very expensive to try and implement one of them because they're essentially fighting the control flow decisions that were made based on one specific one of them at some time. And now it's just this nightmare. And you get poor performance and you get hairy code in there and all sorts of bad things like that. The consequence of moving it too high is the opposite of that. It's that now the upper layer does very little work and expects all the implementations to do most of the work. They can now all be very custom, very efficient, but you got no code reuse. So now, if it turns out that all of those implementations are all basically the same, you just wasted a ton of effort because you could have had all that be shared, and now you've got 10 different substrate layers down there that all have 90% of the code in common, and it's like, okay, that's not so good. So in some circumstances, you will even end up in a situation where you draw the line in more than one place, where you actually have a single API stack, a full stack, for those of you who are full stack developers. You will have a single sort of slice of the API there that actually has multiple cuts. It's got the platform non-specific part, it's got the platform specific part, but in between there may be another layer, which is sometimes there and sometimes not, and that is shared code that is common between some of the platform layers and not others. And so you end up building a 3-tier, 4-tier, who knows, right? It could get very complicated depending on what sort of systems we're talking about, that are based on trying to build up the correct set of cuts through the API that allow you to have the correct implementation everywhere, but without rewriting code unnecessarily throughout all of them. Nobody does any of that right, hardly ever. It's an example of something that's very poorly done. It's why I say API design is definitely a very important skill, and very few people have it. Almost nobody who makes APIs has it. Most of them have no idea, and that is why most APIs are awful. But it's obviously a very important thing for architecture, for APIs, to understand that stuff. It's worth practicing. It's worth getting to understanding how important it is and how all those things work out. It's a very important piece. It's a piece that's not taught very well. It's a piece that's not addressed hardly ever, and it's a piece that a lot of people take for granted, and you end up with the kinds of OS and SDK APIs that we get these days that are pretty awful. Elvin, why don't compilers expose APIs that give us information about our code, like access to the AST? Because when we write top-down parse, we're essentially writing something that the compiler already has. That is an excellent question. And the answer to that question is because the C++ Standard Committee is, again, some of the worst designers that have ever come together to make a language. All of that stuff should have been built in. There is zero question about it. In my mind, I've never been sure of anything else in my life than that meta information should have been a part of the C++ spec from the very beginning. But what do you want? And so the compiler vendors don't have a lot of incentive to provide that, because they know that most people target more than one platform. If they provide this information, it doesn't really do anyone any good, because they're not going to target it because it only exists in that compiler, right? Furthermore, they'd have to design it all themselves and maintain it all themselves. And that's just not something the compiler vendors tend to do. That said, it has happened. It has already happened before. The compiler called Montana, it was written at IBM. It was a wonderful idea for a C++ compiler. Unfortunately, it was trapped inside a product called Visual Age that nobody wanted and nobody used, and which is now gone. But it was Visual Age version 5, 6, 11, 13, I have no idea. The code name for the compiler was Montana, and it did exactly that. It actually was obviously a bunch of people who actually got it. They actually knew what they were doing. Unfortunately, they were not the people working at Microsoft or working on compilers that still existed. But what they did with the compiler was great. It required no header files. It was an incremental compiler, just like John Blow wrote for JAI, where you don't need to pre-declare anything. It was a C++ compiler that just did incremental wavefront. So no declarations necessary. Thing one. Thing two, it exposed that information that you're talking about via a plugin API, so you could write your own hookups to it that did compilation passes, modified stuff. It basically had like an open architecture for hooking into it and attaching to it. And I don't mean like the kind like LLVM where you have to then go like build the compiler to do it. I mean like you could just build like a DLL that would like interface with them and it would work, right? So it has been done before. Unfortunately, for a lot of other reasons, it was never something that was really available in a way that anyone could use. It was trapped inside this, big corporate weird product that, wasn't really going to be relevant to anyone. But it was tried and did work. And unfortunately, that wasn't the lineage for a number of other reasons that we're left with today, so we don't get to having those benefits, unfortunately. Are you still using the software renderer? Yes. We render in software. At what point does a person become a good programmer? When do you think you became a good programmer? I think I became a good programmer sometime around when I was 16. I've been programming since I was 7. I think I got better at programming. I was reasonably good at 16. I then became really bad at programming when I was 19. That's because I was introduced to C++ and object-oriented programming, and I thought, I believed people when they said it was good. And then I was a really bad programmer for about 4 or 5 years. And then when I went back to and realized that was all awful with the help of some very good friends, Jeff Roberts, John Miles, the folks at Rad Game Tools, kind of like not really telling me, they weren't like, you got to stop this, but just kind of being there and kind of constantly sort of being a good example. I kind of came around to it and was like, oh yeah, this stuff is all really pretty dumb, huh? And then I think I've been a decent programmer since then. Again, it took me a while to come back, but I think I've been a pretty decent programmer since then. How do you handle programmer burnout, depression? Those days when you're just not in the mood to do anything, not productive, you're demotivated, you can barely do any coding, you'd rather do anything else other than what you should be doing. I would say that I wouldn't worry about it too much. Everyone has that problem. The thing to do is always write an hour or 2 of code a day during that time anyway. I don't care what it is. Whatever it is that you're working on and that you're stuck on, that you don't know how to do and you don't want to do, type something in. I don't care how lousy it is. I don't care how far it is from an actual usable solution to the problem that you have. I don't care how much you know you're going to rewrite it later. The #1 cure for programmer burnout and depression is to write code. Because invariably, once you get a little further over the hump that you're on, you realize that it's all code you can do, and you start to focus on actually doing it, and then you're out of the funk. And so much like doing anything else, like writing a book or anything else, it's when you get in a psychological state where you've decided that you're stuck or that you can't do it or whatever, that is what's stopping you from going forwards, not the actual failure of knowledge. Because the truth is you just got to something you don't know how to do yet, and that's fine. The way you get over that is by experimentation, typing stuff in, running the compiler, make small goals for yourself, whatever you need to do. Do that. Just keep the code going, and you will get out of it. If you allow yourself to lock up entirely, then you won't, and you'll go for days without having done anything, and that's really bad. In the Ferdy, do you really prefer to save 2 unconditional jumps so the CPU pipeline won't be flushed at any chance, instead of compiler and platform independence referring to get thread ID part? So first of all, there would be no platform independence, because the way you would do that on Windows and the way you do that on Linux are probably different, right? So you need to make a different function call, presumably on Linux, than you would on Windows or, say, on Mac. So there's no platform independence. It's only compiler independence. There's only one compiler for this platform. And unsurprisingly, there's only one compiler for the other platforms. We are only ever going to compile with MSVC on Windows probably, and if we switch to another compiler, we just switch to that compiler. We wouldn't still compile with MSVC. We're only going to compile with LLVM on Linux, and we're only going to compile with the LLVM Xcode branch on Mac. So why add 2 jumps to every counter when you get nothing for it, right? Seems like a really bad decision. Let's see. Why are you making an engine instead of a game? Well, I'm making both, right? I don't really think of those 2 things as being all that separate. But in order to, because I decided I wanted to start from scratch so that everyone could see how to make everything, I have to implement all of the pieces of an engine first. But we've done most of that. So we don't have a whole lot left to do, and then we can do game stuff as well. But as for why I would make that decision, there's a huge number of reasons. Number 1 is I am an engine programmer. That's what I do. I am not here to show you how to make a game. making a game is a separate discipline. I am here to show how you do engine programming. And so it doesn't really make any sense for me to not make an engine, because the whole point of the stream is to show you how you make an engine. And we are making a game as well. And so to that extent, I will be showing how to make a game. But that is because the engine and the game are very, closely related. And obviously, if I just showed you how to make an engine, there's a whole bunch of stuff that's very difficult to teach and show, because it's like, well, why are we doing this? Without a game there to motivate why we wrote the code, If we don't need the bullet to collide with the statue and have the statue fracture, we don't know why we are writing this collision detection code, and we don't know why we are writing this statue crumbling stuff, right? And so to that extent, the reason that it is a game and an engine together is because I feel like that is the way to learn. It shows you why everything gets written. So that you don't have to wonder why I'm putting in, this or that feature, or why I'm implementing something the way I'm implementing it. I can always point out, oh, I'm writing this piece of code because we're trying to make it so that the world can be extremely large, so I need to store it sparsely or something, right? If I don't have that in mind, then, if there's no game, then you wouldn't know. Maybe you don't need that. Maybe, if it's a game that just takes place on one screen, why am I doing that feature, right? So I tried to pick a game as well, and a game design that has all of the things I want to teach, so that it can constantly motivate, the code in that way. Hopefully that makes some sense to you. Let's see. Do you think implementing a regex matcher is worth it, useful for metaprogramming? No, I don't do it. I don't really like regexes. I never have. I don't care for them. I think they're too simplistic. Obi-Wan, you seem to be pretty unhappy with the quality of my software. Do you think programmers were better in the past? Is the software you produce always flawless and bugless? As asking seriously, just trying to understand your point more clearly. No. I don't think anyone really ever produces software that's flawless and bugless. I mean, maybe once in a while you get really lucky and you hit some sweet spot. But yes, programmers were much better in the past, significantly better than they are today. The reason for that was because it was very hard just to do basic programming. And so really the only people who were programming in the past were people who could pass a certain level of quality in terms of what they knew how to do and how good they were, in my opinion. So there was a natural selection process. Nowadays, anyone can program. Like it's trivial. You can just load up some PHP script and start quote unquote programming. So I don't think there are less great programmers today than there were in the past. There's just a lot more bad programmers. So however many good programmers there are probably hasn't changed that much. But the number of bad programmers has skyrocketed. As a result, most software doesn't work at all. Oftentimes on the stream, you even see that happen. Yesterday, we had a pretty hilarious thing where I just wanted to play a movie. The first movie player I tried crashed. The second movie I went through all these different things. It started asking me if I wanted to install a storefront, and then it couldn't play the video because it didn't have the codec and couldn't find it. It was and you're just like, yep, that's modern software, And so as far as saying, is everything I produce flawless and bugless? No, absolutely not. But what I will say is, I try to have a certain quality bar that I get my software to. And I don't just, sort of put out whatever the random thing is that happens to work in some giant stack of garbage that's super slow and buggy and all this other stuff. I try not to ship that, right? Whereas a lot of people just ship that and they're fine with that and they don't see a problem with it. Like Facebook apparently doesn't see a problem with shipping their Facebook app, and that's insane to me. I don't understand how you do that. I don't understand how you can't look at the Facebook app on the iPhone and go oh my God, we need to completely change our engineering practices. This is an epic disaster. That's not what they say. And they write blog posts about how good they did or stuff. And you're just that's more my problem with things. It's if you put out the Facebook app and you were wow, we're really awful, we're sorry, this is the best we could do, we don't really know what we're doing, we're all taking a voluntary pay cut, and we apologize. That's different than we're great, and here's our app that's absolutely ridiculously bad and huge and a nightmare and like it's slow to use and everything else, right? So yeah, so I think there's definitely a thing there. And what I will say as well is like, you know, I've definitely learned my lesson to over time. You know, I feel like if anything, my quality bar is actually lower than it should be. Like I don't feel like I'm that high actually, right? And that's the other thing that troubles me. When I think of myself ranked against meticulousness on programmers, I'm low compared to programmers that I respect, right? I'm not like the guy who demands the most flawless, bugless code. I'm far from that guy, right? And so that's like another kind of troubling thing about it in my mind, is that I shouldn't be the one telling you your software is bad, right? If you've crossed below my bar, you're really low. You're way below acceptable because I'm not that high on the on that side of things. I'm okay letting things slide. Like, you know, Jeff Roberts' performance bar compared to mine, it's night and day. Things that I think are totally fine performance-wise and I'm okay with them, he thinks are not even close to where they need to be performance-wise, right? So if you're below my bar, I don't even know what to say to you, right? I don't know how you get down there. In the old days, yeah, I guess what I'd say is, you know, when I got into programming, when I sort of got out of like high school and started, you know, programming professionally, I was the bottom of the barrel on those opinions, right? And that hasn't changed. All the guys that I was programming with at those times, you know, they have higher performance standards than I do. They know more about optimization than I do. And that really hasn't changed. What's changed is the industry is necrotic. I mean, the number of people who accept absolutely awful levels of reliability and performance is just staggeringly bad. And you know, if I could just say, you know, if I could leave with one, if I could sum that in one thought, it really is, if you are below my quality and performance bar, you are in trouble because I am not the high watermark, opinion-wise, by a drastic delta. By, you know, drastic. Let's see. All right, I think most of the rest of the stuff I can't really address in a short amount of time, so I'm going to wrap it up. I'm going to go ahead and wrap it up. Let's close it down. Pretty happy with where we ended up today, actually, because I think that puts us in good shape tomorrow for having a pretty nice system set up and kind of like, oh yeah, yeah. So anyway, thank you very much for joining me for another episode of Handmade Hero. It was a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game, and it comes with the source code even just right now. If you would like to play around with it, you can go ahead and do so and experiment, have some fun. You can do that just by clicking on the little pre-order button. We also have a Patreon page if you want to support the video series. That's the place to do it. It's always very much appreciated. We also have a forum site. The forums is a place to ask questions. You can look at an annotated episode guide. There's all kinds of good stuff there. So if you're interested in following along the series, that's a good place to check out. We also have a tweet bot. The tweet bot tweets the schedule at you. So if you're trying to catch the schedule live at any given time, you can go there and see what the schedule is going to be for the week or that day or that sort of stuff. As for that schedule, I will be back here at 5 p.m. Pacific Daylight Time tomorrow. So if you want to see us, go ahead and start collating that new debug info that we got in a way that we can then use that'll kind of span across the platform and let us really start to take a look at things and see how our code works, which I'm pretty excited about, honestly. Right back here, 5 p.m. tomorrow. That's the place to be. Hope to see you all there. Until then, please have fun coding, and I'll see you guys on the internet. Take it easy, everyone.